on the last one, since we're dividing into 8 subintervals, I've made 8 rectangles. And we're going from 1 to 3. So what I've conveniently done is said, okay, this is actually x equals 1, and this is actually x equals 3 where I finish. And I made 8 rectangles in between those, since that's all I was interested in doing anyways. And these are currently the right endpoints, since the blue line I'm drawing is to the right. And I could go back and actually start at the right endpoint and then draw it in. And I know that my area formula then is from 1 to 8, because I'm starting with the first x right here, which is the first line that I drew in. And I'm stopping at the 8th line I drew in. And of course, delta x times f of x sub I. So now, if I want to find how wide each rectangle is, remember there's 8 of them, and I went between 1 and 3. So I would want to subtract so I can figure out the whole distance between them, and then divide that whole distance by 8. So delta x is a fourth. I'm going to need f of x sub I, but first I'll have to find x sub I. And any x value that I would find, remember those are all these values here, is from starting at the first x value, which was 1. We call that first one wherever a is. And then adding delta x, and maybe another delta x, and maybe another delta x, and maybe another delta x. So some amount of delta x dependent upon which number I'm plugging in or which I value I'm on. Like, is it the first one? Is it the second one? Is it the third one? So it's dependent upon I. And so in this particular case, a is 1 because that's where we started. Our delta x we just found out is a fourth. I, so there's my x sub I. And so now I need f of that. And so I'll use my formula, which says anything I give you, you're supposed to plug in place of x. So it'll be 1 plus 1/4 I squared plus 5. So that's all the information that I want to keep handy because I got to plug it in over here. So now my area looks like this. From 1 to 8, delta x is a fourth, and f of x sub I is all of that stuff I just wrote down. Okay, so let's see if we can simplify this and actually come up with the sum. And we're going to utilize the hamster, so take your hamsters out so that we can get to one of these values quicker. So now remember, I can pull this coefficient to the front, so it now looks like this. And then I have 2 terms that are being added. That's one of the terms. And my 5 is the second term. So I'm allowed to split them. I could put some brackets here. And it's going to look like this. And then I know this part is nothing more than a string of 8 5s, so that's 40. And I could most definitely FOIL all this, distribute the -1. I'll end up with 3 terms. I'll have one that's a constant, one that has an I, and one that has an I squared. And so I could split those because they'd be joined with addition and subtraction. And I certainly have rules for I, summation of I, and I have another rule for the summation of I squared. But we're going to cheat and use our hamsters because I want you to know how to do these on calculator. In the event this is on the calculator portion of the AP test, you would be able to use your calculator and get some of this a whole lot faster. So the first thing you're going to need to access is second stat, which is technically list operators. And the first time you're going to choose math, number 5, which is sum. And then you're going to go back to the same spot but choose ops, which is number 5, and number 5, which is sequence. So we're trying to find the sum of a sequence. And so the command we're putting in is sum and then sequence. And then you have to give it the formula. So the formula we're using is all of this. Actually, for this particular piece, let's even move this coefficient right here. And so we'll just make our answer negative, and then we don't have to worry about that piece. So we're going to type in 1 plus 1/4. Now, you don't have an I to use as a variable in your calculator because it thinks I is imaginary numbers. You have X. So we have to use the X button because that's our variable button squared. So there's that formula. And then we have to tell it the variable we're subbing in for. Well, we're subbing in for X every time. And then we have to tell it what value we're going to sub in first. Well, we're going to sub in 1 first. And then the number we're subbing in last, and we're subbing in 8 last. And when I do all of that, I get 38.75. And so negative 38.75 plus 40 times 1/4. I think this turns out to be 1.25, right? So 5/4 means I get 5/16. Okay, let's look and see what happens if we do the left sum. Now remember, the only thing that changes really on the left sum is this time I start at 0 and go to 7. So I'm looking at the left side. So I would have started with the 0th side, and then the first, and then the second, and the third, and the fourth, and the fifth, and the sixth, and the 7th. Because those are what determine essentially those little orange staircases, and they determine the height of those rectangles. So all the way up to the top of the orange is a rectangle. So this is rectangle 8, and this is rectangle 7, and so forth. So now it's the left side that determines the height. And of course I have delta x and f of x sub I. So now when I sub in, it looks very similar to the last one. Again, the only difference being my lower bound and my upper bound. And I'm going to work this all the same way. I'm going to pull that 1/4 to the front, because it goes with the whole thing. And then I'm going to split them. Notice I pulled the negative to the front in the first piece. Notice the summation is the same. When I split it, they both go from 0 to 7. And so now I know the value for the last one. I have 8 5s. Now you have to think about why there's 8 of them there. Because I start by plugging in 0, so I'd get, for the 0th term there'd be a 5, and for the first term there'd be a 5, and for the second term there'd be a 5, all the way up to the 7th term. So remember, this is 0th, first, second, up to 7th. But because I counted this 0th, that's really like having 8, so it's still 40. I know, quite possibly there was a mind-blown moment there. And then I'm going to do the same thing on this one. I'm going to sum the sequence and put the negative here in front. And it's 1 plus 1/4 I quantity squared. There's the formula. Oh, I forgot I need an x. I need to use x because I don't have an I. So use x. And then the variable I'm substituting in for, so I'm substituting in x. But this time I want to go from 0 to 7. And so I got negative 30.75. Note to self about using the calculator. It's going to automatically put in a parentheses right after the word sequence. You want your formula in its own set of parentheses. And then this parentheses matches up with this last one to close the whole set. If you don't do that, it's going to give you an error. And so then I'll have, what is that, 9.25? 9.25, I think, check my math, over 4. And if I turn that into a fraction, I believe it is 37/16. I know this is the right fraction. I'm not sure about this one,